All right, everybody, welcome to Math in a Minute. And today we're going to talk about solving linear systems when you have two or more linear equations by graphing and by substitution. All right, to start with, a system of equations is just when you have two or more linear equations. And technically, actually, you can have systems of equations that are not linear, but we're really doing linear. And there are three types of solutions. The first one is the one we really care about, and there are an infinite number of these. But if you have one line and you have a second line, there is one solution. Since each line, when you draw that, every single point on that line is a solution to whatever its function is. So let's call this one f of x. f1 of x, and the second line we're going to call f2 of x. So every single number of the infinite points that are represented on this line here, those are solutions to f2 of x. And so there's exactly one place, there's one point right here that actually solves both f1 of x and f2 of x. And so pretty much your one solution is the intersection of the lines. There can be no solutions, and that happens when the lines are parallel, because they never intersect. And so parallel lines result in this. And just as a reminder, for parallel, the slopes are equal. And the third possibility is infinite solution. The only way that can happen is if they're actually the same line. I didn't draw that too well, but just pretend it's one thick line. And they're the same line. So the one we care about the most is this one. So we want to learn how can we solve both graphically and algebraically for that intersection point. Occasionally, though, when we work problems, we will find times when we have parallel lines, and then, I didn't spell that right, parallel, and then the slopes are going to be equal and there's going to be no solution. And occasionally we'll see where it's really the same line, it's just that it's been scaled by some number, and so it's not immediately apparent that it's the same line. So we will do all three, but mostly the first. Right. So pretty much in terms of solving graphically, we're going to use Desmos. And so we will go into Desmos, and you'll type in the first place y equals 5, second place y equals 2x plus 7, or whatever our equations are, and Desmos will plot them. You can change the colors if you want. And then wherever they intersect, actually Desmos is so nice that if you hover your mouse, your cursor right over the intersection point, it actually pops up with the answer. And so for these two lines, graphically, the intersection happens at the point -1, 5. And so we're basically saying -1, 5 is a solution to both lines. It's always good to check that. And so for the first one, no matter what x you put in, y is going to be 5. And so for the first one, that's clearly correct. For the second one, let's put in -1 for x and make sure we get 5. Oops, -1 times 2 plus 7. So again, if you were this function, 2x plus 7, if I toss you -1 as your input, you need to multiply by 2 and add 7. So you're going to -2 plus 7, or 5. So that checks. It's an algebraic check to the graphical solution. Now if we wanted to do it algebraically to begin with, because the algebra part's pretty fun, you start by, it's already done for us here, but your first step is to solve one of the equations by isolating a variable, either for x or y, and then you substitute the resulting equation from step 1 into the other equation. Then you solve, and then you substitute your answer from step 3 back into either equation to find what the answer is for the other variable. So in this case, it was done for us pretty nicely already. So y equals 5 is easy to substitute. And the reason I can do this, fundamentally, are just the laws of algebra. So if y is equal to 5, and y is also equal to 2x plus 7, then I can substitute for this y the other thing that's equal to y. So I can, this is actually step 2, I can just write 5 is equal to 2x plus 7. So if this was a more complicated expression here, whatever it was, if it was x squared plus 2x plus 2, I could put all of that in where I see y. That's really fundamentally what algebra is. It's the equal sign. So step 3 is we're now going to solve. So let's subtract 7 from both sides. That leaves us with minus 2 equals 2x. Divide by 2, and we'll find that x equals minus 1. So then you would actually go back and substitute this x equals minus 1 into either equation. So if we substitute into the first equation, we know what comes out is y is 5. That's always the output. We can also stick it in here, which we actually did on the last slide when we were checking. So if I want to solve for y, I would put in 2 times this x. So I'm solving for the y that happens at x equals minus 1. And so I'll get it equals minus 2 plus 7, or 5. So this is the algebraic method, and we again determined that minus 1 comma 5 is the solution to both equations. All right. So now we have several practice homework problems, and I'm only going to do one in the video. So I have gone ahead and put Desmos on each one, and I'm going to choose the second one just because I think this one's, because it's already got a definition for y, it's already isolated, that one's easier. So I'm going to do this one. So we have, our two equations are 6x minus 5y equals minus 28, and 7x plus y equals 22. So I put both of those in Desmos, and you can see the intersection point happens over here at x equals 2 and y equals 8. But let's solve for that algebraically. So when I look at these two, I want to pick the easiest possible way to isolate a variable. So step 1 is to isolate. So the easiest one by far is number 2, and I'm going to subtract 7x from both sides. So I'll end up with y is equal to minus 7x plus 22. Step 2, I'm going to take this expression for y, and I'm going to substitute it into the other equation. So I'm going to say 6x minus 5, and now, where I see y, I can write what y is equal to. It's equal to minus 7x plus 22 at this particular intersection of the two equations. And I end my parentheses, and that's equal to minus 28. And then step 3 is to solve that. So I have 6x. So minus 5 times minus 7x is going to be plus 35x. Minus 5 times plus 22 is going to stress my mental calculations here. So I have 0, carry 1, it's minus 110 is equal to minus 28. We can combine these two, so I have 41x minus 110 is equal to minus 28. And then I can add 110 to both sides. I'm going to get 41x is equal to, let's see, so it'd be 18 below 100, so 8 below 90, so that would give me 82. Divide both sides by 41, and x is equal to 2. Right, step 4, I can take either equation and now substitute this x to solve for y. So I'll pick the easier one, number 2. So 7 times 2 plus y has to equal 22. So we've got 14 plus y equals 22. Subtract 14 from both sides. And I'm going to get y is equal to 8. So my solution to these two equations is the point 2 comma 8, just like we found in Desmos. And again, the reason, so y is equal, or I can say and substitute right here, because I'm looking specifically for the point that solves both equations. So that's why it's legal for me to substitute in this y equals minus 7x plus 22 into the other equation, because I'm looking for a place that is this specific y where they're the same. All right. Thank you very much, and we will work the rest in class.